All right. Okay. What we're going to cover today, so we covered move semantics, copy semantics, the basics of class structures. Two things that we're going to cover today to fill out our knowledge of object-oriented programming in C++. One is namespaces, the other is inheritance. And both of these aren't necessarily C++ specific concepts, especially with inheritance. So what we'll do is we'll cover some of the things that are specific to C++, and then we'll leave you guys to either cover it in 106B or in classes like 108 if you want to learn more about it. But to begin with, so on slide 3, this is the first of the last 4 lectures. So as a reminder, we don't have class in week 10, so that you guys can enjoy your true dead week, at least from us. If we take a look at the map so far of where we've come. So this is on slide 4. It's the map that we showed to you that we showed you guys way back in the beginning of the class. And if you take a look at it, you can see how much you've learned so far. So we've covered all the fundamentals. We've gone through the standard template library. In object-oriented programming, we switched things up a bit to accommodate Avery's schedule. So we removed multi-threading. We've covered special member functions and move semantics. Special member functions were the copy, assignment, and constructor. And then today we're going to be covering inheritance. This Thursday we'll be covering template classes. Next Tuesday we'll be covering RAII and smart pointers. And then for the final lecture, we'll be leaving it to you guys to vote on what topic you want to cover. So that'll either be we could talk about multi-threading, we could talk about makefiles, we could talk about blockchain, we could talk about whatever you guys are interested in. So we'll send out a survey for that sometime later this week or beginning of next week. So keep an eye out for that. Okay. So if you guys take a look at the slide that says review from last time of operators, I want you to click that link. And that should take you to the page that says operator overloading on cbpreference.com. I wanted to bring this up just as a reference for you guys. So Avery's been talking about operator overloading, copy, move functions, and you'll remember there were a couple of tricky things in there. One of them being, for example, if you Control F on this page or Command F and go down to the assignment operator, you'll notice that it actually has an example template of what an assignment operator looks like. So specifically, one of the tricky things that we mentioned was checking that this wasn't a self-assignment, so that this doesn't equal the reference to other. And so in case that's something that you would forget normally, this site is a really good way if you are writing your own class to go back and understand what assumptions should your own defined copy or move operator overload still satisfy in order to work well with other classes in the C++ library. So this is just a really good reference. Some other things that you can notice from here, if you scroll down to something like the relational operators, you'll notice that for a lot of the operators that are similar to each other, so something like the greater than and the less than, or the plus plus and the minus minus, well, maybe not necessarily those ones, but you'll notice that a lot of them are defined in terms of other operators. That's another really good stylistic thing to take away if you're trying to write your own class, is that when you're writing your own operators, you'll tend to start writing them, once you've defined one, to write them in terms of the other operators. And again, this page will have example templates of what sort of assumptions should your operator overload satisfy. So yeah, take a look through that on your own time. A really useful resource, and just wanted to let you guys know that it was out there. Awesome. Okay, so back to the slides. One other thing I wanted to review from last time is someone asked a really good question about why learn about move in particular. So we learned about copy. Why does the move function exist? Can someone actually tell me what is the benefit of the move function over the copy function, copy constructors and assignments? Yeah, go for it.
It moves the data from an L value to an R value. so that you're saving a lot of the memory, you're not creating an extra copy?
Exactly, exactly. So the entire intent of the move is really just to avoid using extra memory where you don't have to. And the answer we gave last time was something like, okay, yeah, so it really is just all about efficiency, and that's really useful for when you're working with small devices like Internet of Things devices, things that don't have much memory. But one thing that I think would be really nice to mention is that move is actually really useful, even not just for edge cases like those, but even just for the normal programs that you write. And to give an example of this, back when move semantics were being introduced in C++11, it was actually a really exciting thing for the community. And the reason for that is this. Imagine that you have a program that you've written, and once C++11 came out, you could just click recompile and it would work twice as quickly. That is what the move semantics did. And the reason for that is because a lot of the built-in types for the C++ library had move functions written in move constructors and assignments written in for them with the release of C++11, meaning that any time there was an equal sign in your code, where before that was a copy assignment or constructor, now just by recompiling with the new C++ version, that turned into a move assignment or constructor. And your code, as Avery showed last time, it improved the code speed by 50%, which is huge. So that's just an example of why this was something that we wanted to spend a whole lecture on teaching. And it's something that we definitely encourage you to use in your own code, especially if you're doing things like defining your own classes. For most of the classes that you'll work with that aren't defined, they usually will have move defined on them already. Awesome. Okay, so now if you take a look at the slides that says challenge mode, how many of you guys remember the lecture about everything const? How many of you remember this challenge question at the very end? You don't necessarily need to have done it. I just want to see if this looks familiar at all. Okay, all right, so this is your chance. I'm going to give you 2 minutes. Talk with a partner, and on the Stanford Honor Code, definitely don't look down at the next slides because they definitely don't have the answer. Talk with a partner and ask yourself, what do each of these 5 const keywords doing? What are they saying? Talk with a partner, give me 2 minutes, and I'll figure out a screen share so we can work on code later. Yes?
I could run back to my class and get my badges after.
Don't worry about it. Don't worry about it. Yeah, there will definitely be.
Whenever you turn to you return the on its name.
Starting with easy, so const and pointer. That means
And I don't know what it comes before my class that is. This is a reference to it. I thought that was with const.
That's why it's
right?
Yeah, I've
So this would be
This one is like constant pointer, this constant, this one is like pointer, constant, and the parameter.
What is this?
Yeah.
So I think this is the same one. And then I have some returns in constant to make sure your input points to a constant.
Wait, could you repeat again? Why there's two constants?
So, this is the parameter constant, this is a pointer. Remember how we talked about not changing the thing that it's pointing to?
Yes.
Oh, you can Anna.
Yes.
For the screen sharing,
Yes, yeah, thank you. That's a great recommendation.
The pointer
Okay. All right, let's bring it back together. Okay, so yes, Victoria. Yes, okay. Yeah, so Victoria also brought in this great option. If you guys go to the Piazza where I posted the lecture slides, there's a Zoom meeting link. Please join that and let me know if you can see my screen. Question mark. Raise your hand once you can see my screen.
That's on Piazza?
Yes, so it should be under the lecture slides where I posted this. Oh, all right, I'm hearing some people entering home. All right, I'll give you another 30 seconds. See if you can make it. Hello, welcome. All
Is the
right.
meeting ID or personal name ID?
You should be able to, if you click on the link, that should automatically populate the meeting ID.
This is the first time I'm using Zoom, so I had to go through the installation.
Oh, I see. Okay. If you can you also try looking on with someone else, if that takes a while, but if not, you should be able to put in your Stanford ID as the ID.
Did you download it?
All right.
It's just
Who here can still not see the Zoom? Okay. Would you be down to look over someone's shoulder, potentially? Introduce yourself to the person you're sitting next to. I hope you guys all know at least one other person in this class. By the end of today. By the end of today. All right. Okay. Awesome. Yeah, thank you guys for bearing with me. I'm glad that we can all see the screen again. Okay, so let's take this one by one. So who can explain to me, if you're looking at my screen, what is this const keyword doing? Any thoughts? What did you guys talk about? Yeah, Byron, back. Exactly. So, exactly as Byron said, it's saying that as a parameter, this function takes in a const pointer. What is this next const saying? Feel free to shout it out. Yes, Victoria. Exactly. So altogether, this function is taking in a constant pointer to a constant int at a parameter. Yeah, Byron.
Just to be clear, what that means is that the pointer always points to the same piece of memory, so that memory can't be modified.
Exactly. That's a perfect summary. So to repeat that for the microphone, it means that the pointer is always pointing to the same place in memory, and that memory cannot be modified. Exactly. And then same with the return value. What is this next const keyword saying? Yeah, go for it, Mason.
It's returning a constant pointer.
Exactly. And continue. What is this next const saying?
To a constant.
Exactly. And one more time, again, it means both the pointer and the memory is pointing cannot be modified. And then finally, this is the hardest one. What is this last const at the end saying? At the end of the function? Yes, Eva.
It's not changing any of the fields inside of the class.
Exactly. So this is something that was sort of confusing for a lot of people. So the const keyword at the end of a function at the end of the function as a whole is saying that this is a const member function, meaning that if you write a member function and declare it const, this function cannot change any of the private variables in your class of that instance. So a clear way to say that is if you remember Avery talking about the this keyword, and others referring to that particular instance of this class, this function cannot change any of those private variables. Awesome. So this is sort of a trick question. It turns out that this actually isn't a trade-off between which ones to use. These are three different functionalities based on what return value you want, what parameter you want, and whether you want the function to be able to modify the class private variables. So yeah. This was also something that came up in assignment 2. Whenever you're writing your own functions, always double check your two questions. Do I want it to be const? Do I want it to be passed by reference? And things like that. Yeah, Elliot.
In this example, what exactly is param? Is that like, it looks like it's being dereferenced. Like, is the ampersand param what becomes the const pointer to the constant?
Great question. So this goes back to what is the purpose of ampersand in this parameters list. This is a tricky distinction in C++. In this case, the ampersand is just saying that we're passing by reference. So as we normally would, the ampersand is just saying that we're passing by reference. And so param is just a term for whatever parameter you're passing in. So it's saying that what we're doing, to be clear in that parameter part, is we are passing in a const pointer to a const int by reference. So in this case, the reference really is unnecessary because we don't need to pass in a pointer by reference. But yeah, if you're still confused, let's take that out on after class, but that is a great question. Awesome. Okay, so some quick announcements for today. Assignment 2 is due this Thursday. That said, don't forget that you do have late days to use. Everyone has 4 late days if you filled out the intro survey. And I'll be holding office hours. I can't do my normal Thursday ones, but I posted other ones, and check the Piazza if you'd like those. Assignment 1 grades will be going out today or tomorrow. The graders, their deadline is for today. So we'll get those out to you as soon as possible. And if you guys have any questions about your grades, definitely come talk to us. We'd love to like walk through your code or explain, like if you're just interested, what can I do better? We'd also love to do that. And then assignment 3 will be released this Thursday. Again, you only have to do 2 out of the 3 assignments in this class. So if you finished assignment 2 and you did assignment 1, you are completely done, and congratulations. Well, completely done on Thursday when you turn it in. Okay, yeah, does anyone have any questions? And I'm sorry I'm speaking so fast. I'm trying to make up some lost time. Yeah.
So office hours is like in the it says we get office hours on Piazza, and then it has like a link to it's the updated. The link is good.
Exactly, that is the correct link. Yeah. Yeah, good question. Any other questions? All right. And I also just realized I've been forgetting to throw the candy. All right. Well, we'll be working on that. Okay. Let's see. Okay. So in that case, we'll get to namespaces today. Okay, so namespaces are sort of interesting. If we take a look at what we've been working with so far, you guys are actually already been working with namespaces, whether intentionally or not. So you'll remember from the code that we've written that everywhere we've used a lot of STD, standard, whether that's using namespace STD that you've seen in other classes, or using the explicit using declarations such as like using STD cout, etc., etc. We've actually also seen scope resolution when we were writing our own class. So when Avery was implementing string vector with you guys, you'll remember that when we declared the implementations in the .cpp file, we had to write something like string vector : and then the function that we were trying to write. So that's actually another place that we've been seeing scope resolution in action, and we'll actually understand by the end why that's necessary. So why is there something known as namespaces in C++? The motivation for this comes from the idea that from what we've worked with the standard library, we've already seen that it tends to use a lot of common names, things like a string or max or count, and say we wanted to define our own class that also has what seems like a logical function named count. How do we do that? If we wanted to work with both the standard library and our own library, we need some way of differentiating when we're using which type of count. And this can get a little trickier than initially seems. So we're going to actually take a look at what seems like a very innocuous piece of code. So let's take a look at this. Can everyone see the code okay? See nods. Okay, awesome. So let's take a look at this code. What we're doing here, we have a vector of ints, and all we're doing is we're counting the number of times that the value 1 appears in that vector. And then at the end, we'll see out the count, so we can double check that that's running as we expect, and we will get manual count 2. Perfect. So let's say that this was like one part of some really large program that we were writing. And let's say like something like a billion lines later, then we were like, and we're still implementing this in the main function because we don't know about decomposition yet, but that's okay. So a billion lines later, let's say that we want to use the standard algorithms library count function. So this is something that we may or may not have seen before, but in the algorithms library, there's an algorithm known as count, where you can pass in an iterator to the container that you want to count over, and it will return the number of times that appears. So something we can do there would be something like, okay, you know what, I don't like our manual count. Let's try using the C++ library. Takes in a first iterator, so we're going to say v.begin, a second iterator, so v.end, and the third one, the value 1. And that looks pretty good. So we can try running that. Perfect. And we see, okay, it returns 2. And we know that, oh, okay, so we declared using namespace std above, and that was the reason why we didn't need to specify that this was the std count. We already specified it earlier. So one question that we might have is, okay, let's say, again, this is like a huge code base. There's a billion lines in between this, and I don't realize that I actually did have a manual count earlier before. So ignore that error. Naturally, sometime later, I do want to use this algorithms count that the standard library has already defined for us. What do you guys think is going to happen? What would be your instinctive guess? And again, as I'm writing this, I'm like, oh, okay, I've already declared using namespace std, so I don't need to specify that it's std count. What do you think will happen? How many do you think? Well, actually, I won't do this. I won't say how many think it will compile because we're sharing the screen and it's showing an error right there. So let's actually run this and see what does happen, because it's a little counterintuitive, and the error message, if you ever encounter this in your real life, really does not make sense. So this is the error that we saw. Object type int is not a function or function pointer. Count cannot be used as a function. Okay, what is going on? Can someone explain what they think is going on? Why is it throwing that error? So one more time. This is the error that it's throwing. Yes, right in the back.
Might be simplistic, but it's you declare an integer count previously as a integer variable, and now you're trying to use it as a function.
Exactly. So in this case, what we were doing is we were doing something perfectly reasonable. We were declaring a variable called count, which is a perfectly reasonable variable name for what we're trying to do. And then just at some point later in our code, we wanted to use the algorithm count. And as programmers, we expect this to resolve the way that we expect, because count is a variable, and the manual count is a variable, and the algorithm count is a function. But what the compiler sees is that it sees this local variable count, and it thinks that you're trying to call the function operator, the two parentheses, on that local variable. And it's like, you can't do that to an integer like 1. So that's exactly what's happening. And so this is sort of one of the tricky thing about namespaces. And so if we wanted to resolve this, one really easy way that you could do would just be to, even though we've already said using namespace std, you would have to specify that this is the std count. And that would resolve it. That would then print out both 2 and 2 as we expect. Exactly. But this is actually sort of, this is a better example of why it is that earlier in this class we said we prefer that we don't use using namespace std. In fact, what this is sort of equivalent to is, for anyone that's used, say, Python or JavaScript before. So again, this is something called a namespace. So far we've been using the standard namespace, std:::. In Python, there's a similar concept. We say import random, and then to use something from that library, we have to say the library name and then the function on it. And in Python, we also say that doing something like import star from random or something like that is also pretty bad, because you're clogging up your code with a lot of code that you don't need. It's the exact same concept here for why we don't like using namespace std. Rather, what we like using instead is, as you may have seen in the assignment code, something like using std vector, using std cout, using std end out. Okay. Does that make sense so far? Any questions? Okay, so one other thing with namespaces, to give a definition for what a namespace is, it's sort of as it sounds. What it is it's a way for you to group together lines of code or classes that you've declared into a single namespace that you can reference later. So we can write our own namespace. So up till now, we've only been working with the standard namespace, but what we can use here is the syntax for it is namespace, and then let's call our namespace lecture. And then the syntax is we can write something like, let's declare our own count function actually. So we'll say, let's declare a function named count. That takes in a vector and returns the number of elements in it. And just for clarity, let's change that to something like counter. All right. Cool. So if we wanted to use the count function that we just defined in our own namespace, how do you guys think we would do that? So count, and then let's say like lecture count. What do you think would be the syntax for doing that? So instead of std count v.begin, what would be the syntax for it? Yeah, Brian, go for it.
It'd be like lecture count.
Exactly. Exactly. So exactly as we expect, sort of, instead of standard, we're going to use our new defined namespace lecture, and then we can from there count, call count on v and l. And so if we try running that, perfect. We get exactly as we expect. Yeah, Brian, go for it.
If you scroll to the very top of your code, like you have to do the like pound include like vector algorithm.
Yeah.
Even though you already did like using like namespace std, so like why don't you have to do using std count?
So in fact we actually did. Are you talking about the algorithms one down here?
Oh,
yeah.
There, so you don't need it up there.
Yeah, exactly. So that's a great question. So why is it that we could use that we didn't have to declare using std count up here? As it turns out, we totally could. We could use std count, and then that way here we no longer have to specify. Oh, and actually, no, sorry, I take that back. So again, we do have to specify again, even though we say using up there, because we have a local variable that takes precedence over the using declaration that we declared above. Yeah, great questions. Yes,
so
another question.
Even though like std is a namespace, right?
Yes.
You still have to do pound includes.
Yeah, so what is the difference between sort of namespaces and pound includes? So the namespace, you can sort of think of them as two different steps. The first thing you need to do is you need to make the code aware that this other code exists. And so to do that, you use this include statement to sort of bring all of the vector code out from however they're stored in the cloud, maybe, not really, into your program that you're running, and then you use the namespace to mark, okay, out of all of this code that I have in that I have in this program that I'm working with, which one do I want to use? So there's two different steps. First, you have to include the code itself, and then second, you have to define which parts of the code do you want to use. Yeah.
And you don't need to like have an pound include for a lecture because you already have it there.
Exactly. So in this case, we have already literally written, you could in fact write this code into a separate class and then pound include that class. But in this case, you've already included the code yourself in that file. Yeah, good questions. Awesome. Any other questions about namespaces? Yeah, Yuzu.
So you're saying that the include vector includes like many different kinds of vectors, and then std vector is the one that we particularly choose.
Yeah, so in fact, yeah, that's exactly it. So actually rather, the std vector includes only a specific implementation of a vector, but the code still needs to know that the vector that you want to use is in fact the vector from that include bracket vector class. Yeah, so it just needs to, it first needs to bring it in within reach by using the pound include statement, and then it needs to label it with a name so that it knows which vector it's using. Yeah, and so we could actually completely write our own class. So in fact, we could write something like class, our own vector, and then, you know, have all of our normal public, private, do our own things with it. And then that would take in, yes, template. Type name T name, T oh sorry and then in fact what we could do is down here we could actually reference the own vector implementation that we've made. So again these. Okay, I'll have to debug the errors before, but essentially what you can do is once you've declared it in your own namespace, you can use your own vector by doing something like lecture, vector, and then et cetera, et cetera. So that's 100% valid code, assuming that this actually compiled. Yeah, so I will go back and update the syntax there. Yeah, that's a good question. I'll post an update again because I still see a confused look. But yeah, I'll get back to you on that. Yeah, any other questions about namespaces? Okay. And one other thing with namespaces is that there are some sort of small tricky details in terms of if you want to have namespaces within namespaces, things like that. We don't cover them because we sort of figure if you end up in that situation, we want to equip you with enough confidence that you could go out and be able to search up those details on your own. But yeah, this is sort of a general overview of how namespaces in C++ work. But yes, one of the skills we want to equip with is learning how to look up all of the weird small details. But also, feel free to ask us questions if you do have questions about that and you look it up later online. Okay, so to continue with that, for namespaces, it's the same thing in JavaScript, if you're familiar with JavaScript. In JavaScript, we use the require keyword, and then again, to call a function, we have to say the library name dot the function that we want to use. So in C++, it's the exact same thing. In this case, the : the scope resolution is how we identify what library we're working with. Okay. So one question that we might have is, going back to when we were writing our own classes, why is it that we had to label the name of the class in front of all of our definitions of the member variables? It turns out that the reason why we have to do so is sort of similar. It's because we need to let the compiler know which class it is that we're defining a function for. And so to make that clear, up till now and for all of your projects, what you've seen is that there's two files. There's the name of the class.h and the name of the class.cpp. It turns out you can actually name your .cpp file anything you want. You can name it, instead of string vector, you can name it definitely not a string vector, .cpp, and you could still include all the same code and it will compile well. So the reason why we need, when you're writing your own .cpp implementations, you need the scope resolution, is to let the compiler know which header file it is that you're trying to implement. So that's sort of a tidbit in case, because I know for one, I was always forgetting to add the scope resolution because it seemed like it's string vector.cpp, of course it's for string vector. Okay, yeah, any last questions on namespaces before we go on? Namespaces or the scope resolution operator? Yeah,
So
go for
we
it.
should only use using namespace in a CPP file, but not in a header file, is it?
So that's a common piece of style advice, is to use the using namespace like standard only in the CPP file, not the header file. You don't even have to use it in the CPP file, but you are correct that you do prefer not to use it in a header file. And that's because if your class is included by any other class, then you are forcing that class exactly to import the entire standard namespace. So it is better to do it in a .cpp. Even in a .cpp, though, you can also still selectively choose which usings that you're using. But it is okay to use them using namespace there. Yeah, and you would just want to be careful for errors like the ones that we showed before. Yeah,
You said we should pick the specific ones we want, but at what point is it just better to include the whole thing? 100 statements, 1,000 statements.
Yeah, exactly. That's a great point. Okay, what if we're just, using stdcout : for days? That's a great question. And it's that comes back down to the idea of style. So in that case, you are 100% free as programmers to just using namespace standard. Yeah. So all of these are sort of their own give and takes, but whatever is reasonable, whatever is in common sense. Yeah, Brian.
But the motivation for using using std : was to not clutter the stuff up anyway. But if we're doing count include algorithm, I assume algorithm is massive, right? So at that point,
yeah. So yeah, no, that's a great question. So that's actually interesting. So I would have to double check how it is that the compiler is actually processing the pound includes versus the using statements. My initial guess is that even though it includes all of the files, it won't actually. Let me double check back. Let me get back to you so that I don't give you any wrong information. But there is definitely some sort of efficiency by not including the entire namespace, and I'll have to get back to you on exactly why that is. Okay, yeah. So I have that, and I have Yeezy's question. Any other questions? Okay. Awesome. So again, we're going to move on to inheritance. And again, our intent isn't to give you guys sort of a broad understanding of like how to use inheritance, things like that. That's something that you'll get either from taking classes like 108, and or I believe that they do still sometimes cover it in A, B, or X. So if you are interested in building your own classes, I would definitely take a look at just general inheritance. But if you want to build in C++, these are the core things that you need to know. Okay, so to give you guys first a general overview of what inheritance is, the motivation for it comes from a familiar problem. So once again, let's say that we have a file stream and a string stream, and both of them have this insertion operator defined on them. And let's say that we have another class that we want to define a print statement that like does something extra to the stream and then eventually calls that stream insertion operator. And then the same thing for a string stream. It does the same things to that stream and then calls, the only difference is that it has to call different insertion operators on those two streams. How would you guys solve this? What would be your initial intuition for how you would solve this? So again, we would much rather have just a single function that we can call print on both the IF stream and the iString stream. What's something that we know that you might? Yes.
Templates?
Yeah, exactly. Great idea. So we've already seen before, okay, this seems like a familiar problem. Why don't we just use a template? Perfect. And so we just define some sort of stream type name and then let the compiler do the work of creating those two separate functions for us. So this Thursday, we're actually going to be covering something called template classes, which is similar. And it sort of goes back to the question, you'll see what we do with inheritance. It seems almost sort of similar what inheritance does versus what templates do. And so this Thursday, we'll be going over why it is that we would want to use templates versus inheritance or one or the other. So this is to give you guys an intro to another way that you can solve this problem. So again, what we saw with templates before is that it uses sort of an implicit interface. If you remember from Avery's lecture, we were asking what sort of things does this function assume on our behalf? And so there isn't an explicit list, but in this case, the one thing that it's assuming is that, okay, whatever stream it is, it has some sort of insertion operator defined on it. As a side note, another thing that we'll be covering this Thursday is that, in fact, coming up in C++ 20, there is a way to actually explicitly say what operators or functions are defined for are required for your template. So that's actually something really exciting, but that will be next lecture. So that's an aside. So templates are one great solution to this. It turns out there's another solution that is more general to other object-oriented programming languages called inheritance and interfaces. So the way to think about it is that just as in templates where we had an implicit interface, there's something that is called an explicit interface or just an interface, which is actually, it's the simplest form of inheritance in C++. So it's a subset of inheritance in C++. So the way it works is, how many of you guys are familiar with Java? Java in here. Okay, perfect. So something you might have seen from Java is, let's say we define our own interface class where we use the keyword interface, the name of the class, and then later we define a class that implements that interface. In C++, there's the exact same concept that you can mirror as there is in Java. So in C++, the equivalent would be declaring a class called drink, declaring the function that you want to be have as an interface function as virtual, the keyword virtual, and then later declaring your class T that colon is the equivalent of implements drink. Any questions so far? No. Okay. So just to clarify the C++ syntax a little more, so the key things to note are first the use of the word virtual within the interface class, and then notice that in that virtual function, there's sort of this unique syntax that we haven't seen before. We say virtual void, the name of the function, equals 0. So what the equals 0 does is it enforces that any class that inherits that class called drink has to implement a make function, or else it can't be considered a true class, and the compiler will throw an error. So that's again, this is sort of terminology to get you familiar if you ever go on and read about inheritance in C++. This is called a pure virtual function. The pure meaning that the inheriting class has to define that function. Okay. And so just to recap, in C++, there's no interface keyword like there is in Java. Instead, if you want to define an interface, if you want to make your class an interface, the way to do that is to ensure that your class only consists of pure virtual functions. So it's sort of just a definition. To be an interface, a class is a class that consists only of pure virtual functions. And then if you want to implement an interface as another class, then that class has to define all of those pure virtual functions or else it won't compile. Yeah, does that make sense to everyone? This is sort of a weird overview of inheritance. Yes, Yusuf.
I thought the point was to like write less code, but like if we're like labeling it a interface class, but we're like implementing in T, and then we have to re-implement in copy, then we're still writing a lot of code.
Right. Yeah, that's a great question. So the problem that we had before was that we were writing too many instances of the class. So that's actually a really good point. And so an interface indeed doesn't solve the problem that we started out with. Yeah, so that is a perfect point. So an interface actually is solving a different problem than the one that we introduced interfaces with. Interfaces are solving the problem of, let's say that tea and coffee had different make functions. In that case, then you could use drink as a way to still specify the overall design of what a drink looks like, and then just leave the details of how to implement the make functions to the two different classes. But that's absolutely right. The problem that we had before was that the two functions were the same, and so we wanted some way of avoiding having to write the same function twice. Yeah, so a couple different problems that we're solving here. Yes?
So basically, we can never instantiate the base class.
Absolutely, that's a great question. Exactly. So you cannot do something like drank D equals new drink or something like that because it's an interface. So the only classes that can be defined are ones that don't contain any pure virtual functions. Yeah, great question. And then Brian.
Just to elaborate on that, can we have like certain in like the inheritance class? Can we have certain public functions that are actually defined there and others that aren't?
Great question. So can we have certain functions that are defined and others that aren't? That is such a great question that future me went back and told past me to create a slide on it. So what if we do want to define some functions? That's a great question. Yeah, so that's actually something known as abstract classes in C++. Again, this is a lot of terminology. It's just to get you guys familiar with the words because these are specific C++ isms. But the concept should feel somewhat familiar if you've seen inheritance before. So if a class has at least one pure virtual function, then it's called an abstract class. And going back to the question before, exactly, abstract classes cannot be instantiated. So only classes that have no pure virtual functions can be instantiated. So for example, let's say we had a base class, then in that class we could have a pure virtual function, meaning that any classes that inherit from it have to implement that function. We could have a non-pure virtual function, meaning that the base class does implement foo too, but inheriting classes can overwrite that function with their own implementation. And then finally, we can have our own regular functions where we return the meaning of life. Yeah, any questions so far? Those are good questions. Yes?
Could you go back to the slide where we implement the drink?
Yes.
Yeah, this one. What does the keyword public do in the class T definition?
Yeah, great question. So we see that it says class T : public drink. So the public keyword is actually, it's one of three possible what are known as access specifier keywords. I wrote slides on them, but I actually anticipated that we wouldn't cover them till next lecture. So the three words are public, private, and protected, which you may have seen before. In this case, what this is saying is it's saying that all public functions from drink are still public functions in T. All protected functions in Drake are still protected functions in T, and all private functions in Drake are not accessible by T. So public Drake is actually the key word that you use most when you're working with classes in C++. And in fact, if you don't specify any access keyword, it'll default to public. So this is what you're most used to so far. More rarely, you'll see things like class T : protected drink or something like that. And that's saying that converts all public functions of drink into protected ones within T. Yes. Yeah. So that is a great question. Yeah.
There's something Jerry said. Actually, like Jerry said that if you don't have it, it defaults to private.
Thank you. No. That's 100% correct. So actually, when it comes to classes, everything defaults to private, and that's one of the big benefits of classes. When it comes to structs, so there's actually an example later on where, right here. So here, when you do struct B, inherit from another struct, that actually defaults to public. So that's one of the key differences between a struct and a class. And yes, thank you for catching me on that. Okay, awesome. So going back to our problem before, knowing now that we can have classes where we do implement the same function that can be inherited by multiple classes, an alternative to solution to our problem is have some general base class that implements a general print function, and then have two classes, the iStream and the iStream stream and the IF stream, that just inherit from that base class, and therefore don't need to re-implement that function. Yeah. Does that make sense so far? There were sort of two different problems that we were solving at the same time. Okay. Awesome. Okay, so as one last aside, when it comes to member variables, so not functions, you can think about them as I guess in this example, you can think about them as acting in the same way as functions do, except when you redefine a member name, even if it's of a different type, what it'll do is it'll make any previously written member names quote hidden. So in this case, if you were to try and call A on struct B, the only A that you would be able to see is the double A. You would not even know that the int A exists. So that's just one last tricky thing about inheritance. And then the rest of this we will cover at the beginning of class next time. There's actually not much left in inheritance, but yeah, the big concepts to take away: pure virtual functions, and then we'll be covering public, private, protected next class. Yeah. Awesome. Thank you guys for bearing with me through these screen share problems, and have a great Tuesday and Wednesday of week 8. And also, come by and pick up a jelly stick. There's like 5 different flavors, so you can take your pick.
Just for one. Sweet, thanks.
What did you call this?
Jelly sticks.
A jelly stick.
I think that might be. Oh, jelly strips. Sorry.
Jelly strips.
Yeah,
So many ways to eat jelly
strips.
Oh yes.
Thank you.
Yeah.
Where did you get these?
From an Asian market.
Also, I just got my code working from the other class, like right before I came here.
I'm so proud.
Yeah.
Oh my gosh.
Yeah, it's a big relief. Need any help cleaning up?
No, thank you though.
Alright. See you Thursday.
See you Thursday.